Hi everyone, welcome back. In this video we'll see an example for round robin algorithm. Generally this round robin algorithm will works on the principle of time quantum, which means when a process allocated the CPU, it will execute for only time quantum amount of time. Later it has to definitely come out and has given chance to the next process. Right? To make it this video more clear, just go with the earlier videos of round robin algorithm and come back this one so that you can get more idea. Here they have given the time quantum, which is of type 2 units, and process ID, arrival time, and they come up with here 2 burst times and 1 IO time. What are the meaning of this one? This example is somewhat different from all the examples what we discussed. Guys, generally what will happen when you are in the ready state and if you allocated the CPU, that means when you are in running state, this is what we call it as burst time. While running, you might require some kind of IO operation, then that waiting state or block state is called as IO operation. Then again it will enter into the ready state, then it will come back to the burst CPU mode. This is what we call it as a burst time. Means totally required 7 units of time in order to complete the particular process P1. Right? So like this it will work. Okay. So without any delay, let's start with the execution part. How it will work. I am trying to draw the Gantt chart. So if you assume this is as a CPU, starts at 0 time, right? When it starts at 0 time, initially we are going to maintain one ready queue where the process are going to maintain. At the 0 time, is there a process there? Yes. Process P1 is there at the 0 unit of time. So immediately P1 will allocate it for you. Okay, and it executes for 2 units of time because of time quantum 2. And it will done by 2 units, right? As it executed, I will remove it, right? By the completion of 2 units, what are the process available for us? One will be P2, means before completion of P2, P1 is arrived in the ready queue. Now, once P1 completed at 2 units of time, again it will add it to the ready queue, right? As P1 done with 2 units, it is left with what? 2 units of time. Next, we'll give chance to P2, which will work for 2 units of time. When it work for 2 units of time, it is left with 1 unit and it done by 4 units of time. As it completes the 4 units of time, P3, P4 is also into the ready queue. And P2 completed, so it will be added to the ready queue once again. Now, P1 got the chance, execute for 2 units of time, completed by 6. Right? As it completes 2 units of time, it is left with the 0 burst time. 0 burst means here it requires IO operation. Means when it will come back after 2 units of IO operation. Means at 8 units of time it will come back and it will enter into the ready queue. That is what you have to understand. Now, as P1 is completing 6 units of time, the P5 also arrived for you, right? So I have to add the P5 to the ready queue. Yes, good? Yes. Next, we'll give chance to P3. P3 execute for 1 unit of time, so left with 0 units. As it executes 1 unit of time, it will complete it by 7 units. Right, guys, as soon as it completes 7 units, it will go for IO operation. Means IO operation how much time? For 1 unit of time IO operation. Means it will also come back by at 8 unit of time. Okay, fine. So that's the reason I am not going to add it to the ready queue again, right? So as soon as 7 units completed, all the process are there in the ready queue, So then I will go with the P4 process. Now P4 process will get the chance and will execute for 2 units of time, and now the time is 9, right? As soon as P4 process is executing, starting from 7 units to 9 units, in the meanwhile process, P1 and P3 getting back because their IO operation is done at 8 units of time. 8 units of time. So we need to add them back into the ready queue because their completions are done. Why I have added in the P1 and P3 order only? Because their arrival times are 0 and P3 arrival time is 3. So that's why I have added. So as they have completed their IO operation, I have added here. IO done. Then as P4 completed its task and it doesn't done its complete task, I will be added to the back to the ready queue. Next, P2 will get the chance. P2 will get the chance. When P2 got the chance, it will be allocated for 1 unit of time and done its process by 10. Process by 10, right? And it will went for IO operation. How much of time IO operation? 1 unit of IO operation. Means it will come back to the ready queue by 11 units. 11 units, right? Guys, P1 and P3 IO operation is done. Good, right? So next P5 will get the chance. P5 will execute for 2 units of time, left with 3. So it will done by 12, right? But if you are able to observe, as it is moving from 10 units to 12 units, in the middle you got 11 units is done, which means P2 arrived. P2 arrived at the interval between 10 to 12. So I will get back to the ready queue once again. Then after completion of P5, that will be added back to the ready queue once again. Now P1 got the chance, executed for 2 units of time, which means it is left with 1 unit of time. It will be done by 14 units. As soon as P1 completes its task, it will be added to the ready queue back. Now turn will be for P3. P3 will get the chance, will execute it for 1 unit of time and complete it by 15. As it done its task, it won't be added to the ready queue. Next turn will be P4. P4 will execute for 2 units of time, and will complete by 70. Guys, next immediately went for IO operation, but here 0 units of IO operation means there is no need to spend time for IO. Just it will directly added to the ready queue because it is 0 units. Next, it will be given chance to P2. P2 will work for, so it is done. P2 will work for 2 units of time and will complete by 90. Right? As it completes, I can cross it. 90. Next, given chance to P5. P5 will execute for 2 units of time and will complete it by 21. Right? Next, he will given chance to, so I have to add here. Next, we will given chance to P1. P1 will get executed for 1 unit of time and will complete by 22. I cannot add back because it is completed its operation completely. Next, we will give chance to P4. P4 will execute for 2 units of time and will execute for 2 units of time, complete by 24, which means now P4 is also done. Now we will get chance to P5 and will execute for 1 unit of time, complete by 25, and went for 2 units of IO operation. 2 units of IO operation. As it went for 2 units of IO operation, CPU has to idle for 2 units because there are no process which are there in the ready queue, so it has to wait for 2 units idle. Then again it will come back to the ready queue, then that will be scheduled for 1 unit of time, so it will complete by 28. So as it complete by 28, so and it is 1 unit of allocated already, so this also done. This way this particular round robin algorithm is going to work. Guys, it might be a little bit difficult, just go with the video 1 to 2 times so that you can get the clear idea, right? What is the schedule length here? L equal to 28 minus 0, which is 28. Then what is the efficiency of the CPU? Efficiency of the CPU is total 28 units allocated, out of which 2 units are wasted, that means 26 into 100 is the efficiency, right? Hope you understood this video clearly. Thank you.